let's talk about compute services. First of all, let's quickly understand what does it mean to have compute services. What is compute referring to? Whenever we want to run an application or execute some code, we need compute power so that these processes, these tasks can be executed. And this is what we can use the Azure Compute Services for. To get access to the computing power to, for example, run applications or execute code in the cloud. We are talking about in the following lectures, especially about the virtual machines. This is the typical compute service, and this is infrastructure as a service. We'll also talk about scale sets and availability sets. These are just sets of virtual machines, and we'll talk about them in the next lecture. The same is also true for DevTest Labs. These are also sets of virtual machines that easily scale up and scale down for development and testing purposes. Then we'll also talk about Azure Virtual Desktop. This is just a virtual desktop, so basically a remote desktop that we can also have access through to the cloud. And we'll also talk about container instances and app services. These are now platform as a service, and they are used to develop and deploy applications in the cloud. And last but not least, we also talk about so-called serverless computing. So for example, Azure Functions where we can execute just code in the cloud. That's what we are going to discuss in the following lectures. And of course, again, we'll also have some live demos to make this a little bit more practical. First of all, let's now start with the so-called Azure Virtual Machines. Now let's talk about the first and most typical example for compute services. These are so-called virtual machines. They are basically software simulations of a real physical server. So this means in the Azure Data Center, we have a physically available server, and this is being virtualized, or at least part of the server, into a simulation of a server. So this is then what we have access to. And this virtualization has a virtual processor, virtual storage, and virtual memory. So everything that we need to have a real server available. But this is just a virtualization of parts of a server that's physically in the data center from Microsoft. And then we can use the internet, just for example our laptop, to get access to this virtual server, and we can use it like a real physical server. Apart from the fact that we can't touch it. But we have everything available. We have complete control also over the software that is installed on this virtual server, on this virtual machine. Also the operating system. So whether we want to install Windows or any other operating system, we can do this. Of course, we also have the responsibility that comes along with this. And this is also the most typical example for infrastructure as a service. A virtual machine is infrastructure as a service. A use case, again, as mentioned, if we, for example, don't have access in our company to a physical server, we can create a virtual machine and use this as our server. And we can customize it to be a web server or a database server. It can be anything that we want. So we have complete control over this. So let's quickly summarize the benefits. First of all, we have complete control over our operating system. So whenever this is necessary and we, for example, need to install our custom applications, and we can do this maybe only with a very specific operating system, and this is maybe a very custom application, then we can use virtual machines, configure them exactly how we want this to be. Of course, along with that also comes the responsibility to really configure, update, and maintain all of the software. So this is now our responsibility to keep everything configured correctly and updated and maintained. Also, what we can do is to use images. So these are basically templates that are pre-configured with one specific operating system, and also there can be additional software installed. And we can even create our custom templates. So one operating system and maybe a set of some development applications that we need, and they can then be reused for other virtual machines. So that's the theory about virtual machines, and now let's put it into practice and have a look at how this looks like in the Azure portal. Let's create there a virtual machine. Let's have a look at how we can now also create a virtual machine in the Azure portal. We can either go to create a resource in here, or in the search bar we can also just search for virtual machine and we also find the related service. So let's select virtual machine, and we can see currently I don't have any virtual machines created yet, but I can create a virtual machine just by clicking on the create button and select Azure Virtual Machine. In here, we have now some basic configurations that we can make to configure and set up our virtual machine. I want to stress at this point that for the exam, this is not important and not necessary to know. This is way too advanced for the exam to know these configurations and how you set up the virtual machine. But I still think this can be beneficial for you to see how this is being set up in practice and to see a live demonstration on this. That's why we first want to start with the subscription. The subscription you can just leave at the default. Probably for you this will be the free trial, and then we also have to define in which resource group this VM will be placed in. We can either select an existing resource group, or we can also create a completely new one. I'm just going to create VM resource group test, and then I will create this resource group. Afterwards, we can define a name of the virtual machine. Best practice, just use VM in the beginning, and we have to also be aware we cannot use any special characters. Therefore, I'm just going to use VM test, and afterwards we can select a region. For example, I can choose Europe, West Europe, and we have afterwards the availability options. This is now where we can create some redundancies. So we have already talked about the availability zones. If we select this option, we can manually choose in which availability zone in that selected region this VM should be placed in. So in our case, we can, for example, select zone 1, and then maybe later on, if we create a second redundant VM, we can maybe choose another availability zone, and like this, create this zone redundancy. But in our case, we can just leave it at no infrastructure redundancy required. And note, later on, we'll also quickly talk about virtual machine scale sets and availability sets. In our case, let's just use no infrastructure redundancy required. Afterwards, we can select the image. This is mainly the operating system, but there can be also some additional pre-configured software already installed on our virtual machine. So we can choose from all of these images by going to see all images, and there we can now select from the existing images. You can see that there are some provided by Microsoft, but also by some third parties. So you can see that also these third parties can publish the images, and we can search in the entire marketplace. So for example, if we want to use our virtual machine as a database server, we could be interested in SQL Server. So we can, for example, search for this and find also now some images with SQL Server already installed. In our case, we are just happy with choosing Windows Server. We can select a version. For example, I'm just choosing Windows Server 29. Generation 1, and now we have to also configure the size of that virtual machine. This is the main factor that is determining the cost of this VM. Also, we can use some spot discount. That's something that we talk about later when we talk about the cost. So basically, it's just some cost-saving options where we can use some unused capacities. So if there are some free capacities, this VM could be used for a reduced price. But we'll talk about this later on as well when we talk about the cost. So in here we have the size. The size is, as mentioned, the number one factor that is determining the cost of our VM. We have a few configurations available. So you see, we have different options in terms of CPU, RAM, data disks, and so on. So of course, depending on what we want to use this VM for, we can choose a different configuration. We see we have some of the general purposes, and then we have also some more specific or more specialized VMs. So for example, something where we need continuous full CPU performance, we have some very specialized VMs. In our case, we can just go with one of the cheaper options. So I'm just going to select this one for $11.86, and I will select this configuration. Afterwards, we have to, of course, configure our account. So later on, we need to log in to this VM, and therefore we need a username and a password. I'm just going to use my first name as a username, and I've also already defined a password. Of course, you need to be sure to follow all of these password requirements. So I'm just going to paste in my password. And also, since we want to connect to this VM through the public internet, we need to allow the selected ports. So in this case, we will use RDP. This is just Remote Desktop Protocol, and this is the method that we use to connect to our virtual machine. So therefore, we select Allow Selected Ports, and in here we choose RDP. And now afterwards, we don't need to make any additional configurations. So this is enough for us, and we can now just review and create. So there will be a quick validation process, and this validation has been passed. And also we can see already the price. So this is how much this VM would cost per hour in this case. So now let's go ahead and create this VM, and afterwards we'll quickly also have a look at how we can connect to this VM in practice. And then after a little bit of time, the deployment is completed, and now we can just directly go to our resource, so to our virtual machine. And in here we can see that the status is currently running. So this virtual machine is currently running. If we would not need this virtual machine anymore, for example, for a specific time, then we can just stop this, which will reduce the cost of the virtual machine. Be aware, this is important, you still will have to pay for the storage until you delete the entire virtual machine. But for example, if we don't need it, we can also just stop it, and like this we can save some cost. What we now want to do is we want to connect to this virtual machine. So we select connect, and in here we find RDP. This is the method we want to use to connect to this virtual machine. In here we can download a file that we use to connect to the virtual machine. So this file we can just open up, and then we can use it to connect to our virtual machine. So we select connect, and then we will be able to enter our credentials. It might be that you get some error message so that you cannot connect to the virtual machine. In this case, make sure that you allow the inbound ports. So to do this, we can go to networking, and in here we can add an additional inbound port rule. So in this case, if we add a rule by selecting add inbound rule, we can choose which sources are allowed to access this virtual machine. So of course, this is not the most secure way to select any in here, but for our test purposes, so that we can easily access this VM, we can select any, and then we use the port. So this is 3389. This is what we want to use the RDP for, and then we can just go and add this rule. We can give it a different name, but this is fine for us. So we add this additional rule, and like this we will be able also to access this VM, and that's what we want to do now. So I want to again open up this file, and then I can just connect to our virtual machine. So I have to choose another user. So I will use my name and then the password that I've created before, and afterwards we will be able to connect to this virtual machine. So we can see the machine is going to be set up, and we can also just minimize the window so that we see this is really just a simulation of a server. So in this case, this will just may take some time until everything is set up. So after a few seconds, we can see this is being set up. We can again minimize it, maximize it, and this is now really just the virtualization of this server. So we can minimize it, and for example, we can now go down. We can see we have all of the options that we also would have on a normal server. And also what we could do is we could, of course, also access the internet if we allow it. And in this case, we could, for example, also just, for example, download some additional software and install it on this server. So this is all possible. Of course, in this case, this server might be a bit slow because it doesn't have so much power, but we could, for example, just go to some website like Microsoft.com, and there we could then download some additional software, configure our server. Of course, this is what we are responsible for with using virtual machines. So this is how we can use a virtual machine. Let me close this session so we can just disconnect from that session. And afterwards, of course, we should also make sure that we are deleting everything again, because we don't want to have any costs that are incurred by this. So let's go directly to our resource group, and we want to delete the entire resource group. So I want to delete that. I can just copy and paste the name and delete the entire resource group. This will just take a little while until this resource group is being deleted. Let's now talk about the so-called availability sets. This is different from the availability zones that we've talked about previously. So as a reminder, the availability zones protect from an entire data center failure. So if one entire data center in a given availability zone is going down, we make sure we still have another availability zone with at least one data center so that not the entire region is going down. And now the availability sets protect against failure within a given data center. For example, a rack-wide failure. And this is achieved by grouping the virtual machines into these availability sets. Now, what does that mean? Let's have a closer look inside our data center. In a data center, if we create a virtual machine, they will be, of course, in a physical location somewhere in our data center. So we have our server racks, and there are multiple servers, and we can create these virtual machines in these servers somewhere in our data center. But now if we create multiple virtual machines, we should make sure to distribute them in a smart way. Because we can have two problems, and this is that one rack, for example, can be connected through a same cooling, powering, and networking. So if they are in the same rack, in this same location, then maybe both of them would be affected if, for example, we have a power outage or a networking failure. And also a second point is that sometimes we need to make updates so we can have some planned downtime as well. And then it also would make sense to distribute them in a way that these updates can be done independently and we don't have a planned downtime of two virtual machines, for example, in the same time. And this is why we use this grouping of placing them into different so-called update domains and fault domains. Now, what are these update and fault domains? The update domain can be rebooted together. This means that if we have one update domain, this can be updated first, and then we have another update domain, which can be then updated afterwards. So they will be separately updated, and that's why it makes sense to distribute the virtual machines across multiple update domains. And the fault domains protect against unplanned downtime. For example, if we have a power outage, some networking failure, in this case, we have these fault domains which have independent cooling, powering, and networking. So that if one is going down, we still have maybe another virtual machine in another fault domain. So let's have a look at how this would look like in practice. We have maybe fault domain 0 and fault domain 1. We also have update domains, and note that these can overlap, so we don't exactly have control over how this looks like in the Azure Data Center. But for example, if we create the first virtual machine, this should be then in the update domain 0 and fault domain 0, and then the next virtual machine within the same availability set should be in a different fault domain and also in a different update domain. So this is what the availability sets are. And don't worry, we don't need to worry about how this is distributed. This will be done automatically by Azure. And now this is important because of the guaranteed availability. This is guaranteed by the service level agreements, and if we, for example, want to make sure that we have at least 99.95% availability, we need 2 or more virtual machines within an availability set. But if we now require 99.99% of availability, we need to have at least 2 virtual machines across 2 different availability zones. This is necessary if we want to achieve 99.99%. This can then not be achieved anymore with 2 or more virtual machines within an availability set. In this case, we need to spread them across 2 availability zones. Now, this was the concept, the theory about these availability sets. And now, of course, we want to put it into practice and have a look at how this looks like in the Azure portal. Now let's have a look at how we can use the availability sets in the Azure portal. For that, we want to create first a new virtual machine. So we can create a new resource, which is a virtual machine. For that, we want to create a new resource group, because if we want to use availability sets, we need to have all of the virtual machines in the same resource group. Therefore, we can just call this resource group availability sets. And then also the virtual machine, let's just call this VM1, and the region we want to use North Europe. And then for the availability options, now we of course use availability set. In here we don't have an availability set created before, therefore we can also create now a new one, because we have to always select a given availability set for this process. So we can just call this availability set 1. We can just leave it at the default values for 2 fault domains and 5 update domains. This is just then distributing all of the virtual machines within this given availability set across these domains. So for example, if I create a third virtual machine, then this will be placed into the first fault domain again. So it will just be distributed evenly across these domains. So let's just click on OK and create also this availability set. And then for the image, we can just again use our Windows server. And then of course we can provide again a password and username. So let's just paste that in here, and afterwards let's now create or go through the validation process and afterwards create this virtual machine. So validation has been passed. Now let's create this virtual machine. Now after 1 or 2 minutes, this deployment has been completed. We can go to our resource, so we can see the status is running. Location is North Europe, so it's important that all of the virtual machines will be in the same resource group as well as in the same location, because otherwise we cannot make use of these availability sets. And now if we scroll down, we can see fault domain under availability is in this case 0. So now if we create a second virtual machine, we can see that this will be then placed into fault domain 1 if we use the same availability set. So let's go and create a second virtual machine. We can go to resource groups. In here we have our resource group where we have created just previously this virtual machine. So now let's create the second virtual machine. We can again just search for virtual machine and then we can create a new VM. In here, we just need to make sure that we select the same resource group. We can give the name VM2. In here also, we need to make sure that we select the same region. So previously, we've selected North Europe. And this is why we now also need to choose North Europe. And in here, we can now select our existing availability set. Now again, let's just use a Windows server. This is not super important, but we want to again, of course, create a username and a password. And now if we go to review and create, everything has been passed. We can now therefore create this second virtual machine. And then after about a minute again, this has been completed as well. So now let's go again to the resource, our second virtual machine. We can see this is also running and the name is VM2. And if we scroll down, we see the same availability set and now it is fault domain 1. And if we now go directly to availability and scaling to all of the details, we see there's not only the fault domain, but also the update domain. And if we go to our availability set, we can see that now in this availability set that we've created, there are now these two virtual machines and we can see the fault domain is different and also the update domain is different for these two virtual machines. In our case, we of course don't need this anymore, therefore we can just delete this entire resource group. So let's go to the resource group and in here we say delete resource group just to make sure that there are no costs anymore related to these virtual machines. Therefore, let's just copy the resource group name, paste it in here and delete all of the resources in this resource group. So this is how we can use the availability sets for our virtual machines. Now let's have a look at the load balancers. A load balancer can help to distribute traffic among virtual machines or other similar systems. So let's have a look at the following use case when this can make sense. In our case, we have a set of virtual machines. And now that we maybe have a lot of virtual machines, so we have scaled this up quite a lot, maybe they function as web hosting servers, and now there's a lot of traffic coming to these virtual machines. How can this traffic now be balanced evenly to these different virtual machines? For this purpose, we can optionally use load balancers. And the job of them is now to distribute the traffic on these virtual machines, depending on the health of these virtual machines. So, for example, we have one virtual machine that is currently having some issues, then no traffic will be sent to this virtual machine. Or we can see that there's one virtual machine that has a lot of capacity, then this will also be all detected by the load balancer, and then the traffic will be sent more to this virtual machine. So this will distribute the traffic to the healthy virtual machines so that we can have a higher availability and a higher network performance. This is what we use load balancers. We can use them both for public traffic as well as internal traffic as well. So that's what we can use load balancers for. In the last lecture, we've learned that a load balancer can help with the availability by distributing the traffic across the virtual machines. But now, what happens if the traffic is getting so high that all of the virtual machines cannot handle this traffic anymore, even though we have this load balancer, because the capacity is just reached with all of these virtual machines. So, of course, what we could do is manually add additional virtual machines. But sometimes our demand is really dynamic. So in the evening, maybe we have much more traffic than in the afternoon, and therefore this manual process is really not the ideal solution. In such situations, we can make use of virtual machine scale sets. They are a set of auto-scaling, load-balanced, identical virtual machines. The fact that they are identical virtual machines, this also includes that they have the same image, the same operating system. This helps to easily scale them up and scale them down depending on the increase and the decrease of the demand. So this makes them very dynamic, and they also have a very high availability guaranteed by Azure of 99.99%. So we can use these scale sets to automatically react to the demand by starting and shutting down additional identical virtual machines. Let's talk about the so-called DevTest Labs. The idea of these DevTest Labs is to enable developers to easily create their own virtual machines for development and testing without increasing the cost and making it too complicated for them. So, for example, we have some developers, and of course, they need to be able in their daily work to quickly create some virtual machines, create some testing environments, and they should be able to do this in a quick manner without asking for complicated requirements and going through a very complicated process. But of course, on the other side, we also want to be able to control this in a way and also control the costs. And this is why we can use these DevTest Labs. These DevTest Lab users can easily and quickly create virtual machines. They can choose from defined artifacts like some predefined development tools like Visual Studio, SQL Server, and other tools that are selected and defined by an administrator. So with these policies, we can define as administrator what tools can be installed, what operating systems these developers are allowed to use in the DevTest Lab, and also, of course, what size of the virtual machine can be used. And like this, we can, as admin, define these policies to just have a control over the cost and still give these developers the ability to quickly provision and shut down virtual machines for development and testing purposes. Let's talk about Azure Virtual Desktop. What is that and why could this be needed? Azure Virtual Desktop is a virtualization of an entire desktop environment, or maybe also just some specific applications. And this virtualization can then be just accessed through a browser. And like this, if you, for example, don't have your working laptop with you, where all of the files, all of the applications that you need are installed, then you can just use any other device that has access to internet, and through the browser you can get access to your virtualized environment with your operating system, with all of your applications and all of the files that you are working on. And this makes you independent from the location, the device that you are using, and maybe also the operating system that is installed on your device. Like this, you can get access to this virtualized environment. And we can not only use one single operating system in this virtualization, but we have a wide range of operating systems that can be used in this virtualization. And also, only specific applications can be virtualized, so that we don't have access to the entire desktop, but maybe just some specific applications. And also we should note that even if we have a very big company, there are no fixed limits on simultaneous user connections. So if we have multiple users that need to work on it in the same time, then this is possible because there is no fixed limit. So this is totally possible, and we can have this simultaneous user connections. But now, what are the real benefits of that? We've already heard that we are independent from the device that we are using and the location, and this is basically decoupling the hardware from our working environment. So our data, all of the applications are not installed on our hardware, but they are just virtualized in the virtual desktop that we get access to through the user. And the main benefit of this is that the security is centralized because we decouple the files, the application, the operating system from the local hardware. And like this, we can, for example, avoid that some confidential data is left on the local hardware because it is just in this virtual environment where the security is completely managed. And of course, we have all of the cloud security features also available. For example, multi-factor authentication and all of these managed security features are also available there. These are the benefits of Azure Virtual Desktop. Sometimes we want to deploy a web application and we don't want to be stressed and manage all of the underlying infrastructure. In this case, we can use Azure App Service. This is a platform as a service offering that we can use to deploy and host our web applications. And here we have just the environment that we can use to manage all of these things for our web application. So for example, of course, we could also just use a virtual machine, set that up, configure that, and there install all of the necessary applications and just struggle with all of this underlying infrastructure. So if we don't want to do this, but we just want to focus on the development of the application, then we could just use Azure App Service to just deploy and manage our web application. Because in there, since this is a platform as a service offering, everything is managed from security to auto-scaling also. Auto-scaling is one feature that is available in the paid plans. So as we know it, we only pay for what we are using, and this is depending on the selected app service plan. So there's a free plan also, which is more for testing and development, because the compute time we have is only like an hour per day. So this is very limited, but there are also multiple paid ones. And if we choose the paid ones, we also have the auto scaling option. So everything is managed and we can just focus on the development. Of course, all of the important programming languages are supported, as well as continuous deployment, for example, via Azure DevOps or GitHub. So all of this is possible and we can make use of. So using the Azure App Service, we can just focus on developing the application. We don't need to worry about the infrastructure and use this offering to deploy and host our web applications. After we've learned about the theory for app services, let's have a look at how this works in practice. We want to create now an app service. So to do this, we can just search for app service. As we know it, we can find app services in here. We can select it. Currently, I don't have any app services yet, but we can create a new one just by clicking on create. Again, we can choose our resource group. We can, in our case, create a new one. So for example, web app resource group. We can say OK. And afterwards, this is now important. We have to choose a web app name that is globally unique. So for example, if I'm just choosing web app, most likely this name is already taken, so we cannot use that anymore. So we have to choose a name that's globally unique. So for example, in our case, I'm just adding my name and maybe a few numbers. So like this, it should be hopefully unique. So yes, we can use this name for our web app. Afterwards, we can select how the content should be published. So we can either use code or some Docker container, which we'll also talk about in just a minute. For now, we can just select code. We have to select a runtime stack. In this case, we can just use .NET 7. And now also the Windows operating system we can leave at Windows, and also the region. Ideally, this is close to where we are, so close to where the users are, so that we have a low latency and a good performance. In my case, I can just choose Europe. So let's just have a look at Europe, North Europe in this case, and this is fine for us. And then we have to choose a pricing plan. this is also determining the cost of our service. In our case, we can change the pricing plan because we can also use a free one. Of course, we have different options available depending on our use case. In our case, we can just go with development and test because this is the one where we have also a free tier. Be aware that in this free tier, of course, we use shared infrastructure. We have only 1 GB memory and only 60 minutes of compute per day. But this is free, and in our case, this is totally enough. So we can just select it and click on apply. And then we are actually already done. So we can have a look at the other options. There's nothing we need to change. We don't need to set up any continuous deployment. Networking also, we don't need to change anything, as well as monitoring. We can leave all of the defaults there as well. So therefore, let's just click on review and create, and then afterwards on create, and then this app service will be deployed. And after just a few seconds, this deployment is completed. Let's go to the resource. This is our app service. We can see the status is running, and now we can have this URL in here. So we remember we had to choose the name uniquely so that this can be accessed through this URL. So if we just open this up in a new tab, we can see that this is now our web app. So we can see the web app is running and waiting now for our content. So now, of course, we could go and deploy some content. So of course, we could use some continuous deployment from GitHub or from Azure DevOps. We could set that up in the deployment center. So in here, we could choose a source, but we just want to set up something very simple. So we can scroll down to development tools. In here, we have the app service editor. In here, we can just go to this editor in which we can also set up something manually. So in here, we can see we already have one file. This is already set up, but we can also just add another file. So for example, let's use the file main.html, and there we can now provide some code. So for example, I can say this should be maybe some heading. So let's say H2, and then we can say hello world, for example. So this is the content of our web app. So for example, let's close the heading again, and then this is saved automatically. And now if we just again refresh the page, we see that currently, of course, we are accessing just the general URL, but we can also just add main.html, and then we see this is the content that we have provided. Maybe we can also change the name of this browser tab in here. So we can, for example, add a title. We can just say title, and then let's say, for example, web app, close the title again. And then again, this is saved automatically. And now if we refresh again, we have now also this title in the browser tab. So like this, we can just use this app service to focus on just developing and deploying our application without worrying about all of the underlying infrastructure. Congratulations on completing this module. I know this was one of the a little bit more challenging modules, and that's why we now just quickly want to summarize what we have learned in this module. First of all, we started to talk about virtual machines. This is a virtualization of a physical server or a computer. Like this, we don't need a physical server in our data center, but we can just virtualize it and use it from Azure. Therefore, this is infrastructure as a service. This means with these virtual machines, we have complete control also over the operating system, all of the software we are installing. Everything is all in our responsibility. Afterwards, we've talked about the virtual machine scale sets. A scale set is a set of auto-scaling, load-balanced, identical virtual machines. Also, they can be sometimes similar, but usually they are really identical, and this can then increase dynamically based on the demand. So usually a set of auto-scaling, load-balanced and identical virtual machines that can increase and decrease depending on the demand. Availability sets is also related to the virtual machines. This is when we group our virtual machines inside a single data center into the fault and the update domain. And this helps us to increase the availability and protect against failure within a data center. So that's important, within the data center, not within the region or within the availability zone, but just within the data center if, for example, a rack fails. And then we've also talked, this is still related to the virtual machines, the DevTest Labs. This is necessary sometimes for development and testing purposes, that specific users, developers, have access to some specific predefined virtual machines. We can use policies to define what kind of artifacts can be used in these virtual machines, what sizes can be used, and like this, these developers can just quickly create these virtual machines without going to a very long process, and still we can keep the cost under control. Then we've talked about Azure Virtual Desktop. This is desktop and application virtualization that is accessible through a browser. And like this, we can decouple the hardware, so maybe the working laptop, from the work environment, maybe the applications, the data that those users need. And like this, there's an increased security because the hardware is decoupled from the data and the applications. We can virtualize different operating systems like Windows Server, Windows 10, Windows 11, and everything, as mentioned, is decoupled from the hardware. Also, it is possible to have multiple user sessions all at the same time. There's no fixed limit on this. This is possible if we have, for example, many employees that need to work in the same user session. Afterwards, we have talked about the app service. This is part of the platform as a service offering, and we can use that to deploy and host our applications without worrying about the underlying infrastructure, the virtual machines that should be there in the back. So this is all completely managed. We can just focus on the development of the application and then just upload and deploy our web applications. There is also auto-scaling options if we choose the plans that offer these features. Then we've talked about the Azure Container Instances. This is also a platform as a service offering. We've learned a container is just a software package with the operating system, including the application. So like this, everything that is needed for this application is in this container. And the Azure Container Instances offer a fast and simple way to upload and run these containers. This is nowadays very mainstream that these containers are used in the microservice strategy. And as mentioned, we don't need to also mention the virtual machines in the background, any of the operating systems. We don't need to take care about this. And last but not least, we've also talked about Azure Kubernetes Services. This is now the orchestration software that is open source, and we can also use it in Azure to just deploy and manage these containers at a scale. So we have a little bit more options that are related to scaling and also connecting them. This is then helpful if we have many containers and we need to work on this at scale. I know this was a little bit of a longer and probably also a bit more challenging module. That's why, again, congratulations on completing this entire module.